Okay. So last time, right? So actually, the the main objective of our course. Okay. Fabricating a PCB. Lab 4 is actually the start of what we need to see, or I will teach you how to fabricate a simple PCB. Okay, wherein you will design a layout from a circuit. Last time I discussed. Okay, so from a small circuit, this is just a small circuit. It's okay. Okay, but for the project we will have a little big circuit. All right, a little big, not like this small, but for discussion purposes, we need to discuss this one. Okay, and as part of lab number 4, we need to check this circuit. We need, so the objective is to transfer again, to transfer this circuit to a board. So we will need to design a layout. We call it a layout, or an artwork. Okay, an artwork is the design or the connection of the PCB on the board. All right. Now, like last time, I told you, if you read your books in lab number 4, you'll find that a PCB layout or an artwork consists of only two shapes. Remember, there are only two shapes you can see in a board. One shape is what we call the pads. Remember, pads. We call it pads. Okay, the circular portion or square wherein you will solder your components, the connection point. You will drill a point here. Later on, you will drill this pads for the component. You insert it and you drill. You solder it. Okay. And another shape is what we call the traces. We call it traces. Okay. So again, there are two shapes only you can find in a PCB layout: a pads and a traces. Okay. Now the question is, how will you transfer this circuit to a board? Okay, designing a layout. All right. So first, you need to know what? You need to know how many pads is needed for a component. Okay, that's one thing. First, okay, you need to know how many pads you need for a component. Like for example, you must be familiar with the kind of components here. What are these? Resistor. We have LED, LED, diodes also. Diode, resistor. We have the source. We have the VGT resistors, right? Or transistors. All right. Now, it's very simple. Like resistor, how many terminals is that? Two. So meaning the number of pads is also equal to the number of terminal. Simple, So meaning, for resistor we need 2 pads. For transistor we need 3 pads. And so on and so forth. Got it? Okay? Got the idea? So now, the next thing, after, okay, determine all the components. So that's the time we need now to put the pads on the board. For example, imagine this is the board, okay? You put the pads here, alright? So again, resistor. First, we need the resistor. How many pads we need? 2 pads. Put 2 pads, So I will place the component the same location as it is, so that you will not be confused. Same location, alright? So R1 goes there. 2 pads first. Next, we need here an RS. An RS is like a 2-wire. Later we will find out what is that. Okay. So there are 2 wires. We need 2 pads also for this one. So 2 pads for RS. 1 and 2. Transistor, we have 3 pads. Correct. So that's why B, C, and E, or base, collector, emitter. 3 pads. Then after that, again we na same location here. R2, 2 pads. Diodes, 2 pads also. Source, which is positive and negative, right? So we need 2 source, or 2 pads also. And the LED here, 2 pads. So after completing all the pads, Okay? The next step is to interconnect the pads. Make the connection between pads by following the connection of the diagram. Like it's like a drawing, simple drawing, connecting. Okay? Like for example, RS, this point goes to the collector. That's why here, going to the collector. See? Then goes to the resistor. Going to the diode. Going to the source. LED. The emitter goes to the LED again on the other side. R1 goes there, and so on and so forth. Right? Simple. Like drawing. You are following only the connection. You got it? Okay? So now that completes now the layout of this simple circuit. You got it? Okay? So it's simple. Okay? Now, the next thing you need to know is, of course, because after you design it, you will drill every pads. Then the next thing is, I will give you components, and you have to laham, to solder the components on the board. Okay? You solder the components on the board. Now, the thing you must know when you are starting soldering, okay? When you are soldering, you must know the characteristic, or not characteristic, the components configuration. We call configuration. Like for example, a transistor. I'll give you this transistor. This is the actual picture transistor. I'll give you later. Okay. I just draw it in a little bigger thing so that you can see it. Okay. So this is the transistor. So in the transistor, when I give you that transistor, you don't know where is the emitter basis collectors. So you must know. This is the thing, right? You must know. Now, how did I find this one? Easy. You can go on Google, type the number of the transistor, and he will give you the information about the terminal. Where is base, where is collector, where is the emitter. So this one is the actual already. I already searched this one. I already look at in Google. I find this information in Google already. I find that this transistor has the emitter here on the side. When you are when you're looking at the transistor by face to face, emitter will be on the left side, base on the middle, collector on the other side. That's all. Because you must know when you are putting it here, you must know the right position where you put the emitter, base, and collector. Sala, you got the idea? Okay. Next also, diode. You must know also diode. Because diode has two terminals, the anode and the cathode. So you cannot reverse it, right? There's a polarity about that, okay? It's important, okay? So you must know where is the proper terminal for cathode and where you put the anode side. Correct? Same thing with LED. LED has a cathode and a anode side. Now, usually, I have a material here. Usually, standard. When you are looking at an LED, there are two terminals, one long and one short. You get the point? Yeah. Longer, otherwise longer. Usually, the longer one is the anode side, and the shorter one is the cathode side. So I'm drawing it. I'm putting it all the information. Got it? Okay. One last thing. Battery, very important. Okay. There's a positive and the negative side. So don't reverse it. It will not work. Or we will burn the component. Alright? There should be positive. Be careful with the positive side and the negative side of the terminal of the source of the battery. Alright? Usually positive represents red color. And the negative represents black color for the wires. Alright? So what else? For resistor, there's no issue, right? For resistor, because there's no polarity, there's nothing there. Even when you reverse, no effect, no problem. It doesn't matter. Salala? Okay? So now, what you will do now is, you have a pencil? No. Okay, anyway, you have a pencil or pen. You will now try to design, alright, the layout here from this circuit like this one. Okay, you can just make this as a reference, okay, for your artwork or for your layout. It doesn't matter, okay. Now again, but first, again, last time I told you, as much as possible, make the pads bigger and make the terminal thicker. Okay, because now we are using manual. I'll give you a special pen later, a special pen. Special pen is fixed pen. To be permanently written here, then we will use some process later, okay? Okay, we will use some process later. Okay, then drilling and so on, okay? So again, take note, make that as much as possible, make the pads bigger and the traces thicker. All right? Okay? Any question? Is it clear?
Yes.
Clear now?
Yes.
That's okay.